Texas consists of a binary liquid explosive, a mixing pumping unit, plastic pipe, and an entrenching machine. The liquid explosive is a binary consisting of inert ingredients, neither of which is classed as an explosive. A mixing and pumping unit, the MPU, is used to prepare and dispense the liquid explosive. The entrenching machine, backhoe, or other ditch digging equipment must be capable of producing a trench at least 8 inches wide and 7 feet deep. No difficulty was experienced during the technical feasibility test at the Tropic Test Center during the production of these trenches in cohesive clay soil. But where these trenches were attempted in sandy soil, the vertical walls of the trenches collapsed as fast as they were produced. The 20-foot lengths of 4-inch pipe were laid out alongside the trench. The pipe was distributed from a standard Army 1 1/2 ton trailer that required no modification for this mission. The excavated soil was piled only on one side of the trench to facilitate the pipe emplacement after the pipe sections had been coupled together. The excavated soil was replaced over the emplaced pipe by a road grader. This trench is 200 meters long. Texas will also function in trenches of 300, 100, and 50 meters in length, as well as in the cratering mode. The 20-foot lengths of pipe were slip-fitted together after careful alignment of the adjoining sections. Once assembled, the slip joints were not immune to the severity of the free fall emplacement of the pipeline into the trench. The joints that slipped apart required reassembly at the bottom of the 10-inch wide trench. The elastomeric O-rings that sealed the slip joints exhibited a high coefficient of friction against the plastic pipe. Even though a lubricant was furnished as part of the Texas system support package, it was found necessary to develop special tooling to facilitate the assembly of the slip joints. The special tool is held by its designer and builder on the right, while another soldier provides the impetus prerequisite to slip joint assembly. The tool was fabricated of steel in a Tropic Test Center shop and consisted of a piece of 1/4 inch thick tread plate, a 6-inch long, 3-inch diameter pipe, and a 3/4 inch diameter rod handle. Other tooling that was not provided with the Texas included this gate valve that was added to the downhill end of the pipe to prevent the blasting agent from flowing out when the fill hose was disconnected. One contractor's slurry explosive consisted of dry aluminum powder as the sensitizer and a sodium perchlorate solution as the oxidizer. Both components of the mixture are stable until mixed together. The mixture cannot be initiated by a number 8 blasting cap. A C4 explosive booster is required to render the mixture unstable. The mixture can be rendered inert by simply flushing with water. This blasting agent is essentially the XM268 formula that resulted from a development effort in the late 1970s by a RADCOM. Loading the liquid and powdered explosives from 55-gallon drums consumed more than an hour of time because each drum of powder must be handled by the hydraulic crane. The mixing and pumping unit is a skid-mounted package that is essentially a scaled-down version of commercial explosive slurry machinery that is mounted on trucks that provide on-site explosives for the mining and quarry industries. This MPU is configured to fit on Army 5-ton cargo trucks and dump trucks. Another contractor's liquid explosive consists of 2 liquid components that can be pumped into the MPU in about 20 minutes. Observations of the Texas detonation were made from rotary wing aircraft as well as from the ground. This 4-inch diameter, 200-meter long pipe contained about 6,000 pounds of blasting agent, including the fill pipes at each end and the external spillage. 4-inch diameter pipe is the minimum size that will produce a reliable detonation. Tests have shown that air entrainment in the slurry during mixing and pumping may cause air bubbles within the pipe. These air bubbles have the potential to absorb the detonation concussion wave as it proceeds through the pipe, thus preventing portions of the blasting agent from being initiated. The pneumatic cushioning effect is intensified with increasing pipe length and decreasing pipe diameter. The detonation concussion wave cannot be sustained in pipes smaller than 3 inches. This aerial view of the trench prior to the detonation shows a grass cover on the ground and also shows large trees close to the trench. A similar view after the explosion shows a uniform distribution of ejecta from the explosively excavated ditch and also shows the removal of virtually all vegetation adjacent to the ditch. Texas is designed to crater roads, to destroy bridges, to create anti-tank ditches, to create defilade positions, to create rubble obstacles in urban areas, to remove obstacles, and for general purpose demolition. This illustration shows a typical section through the ditch. The excavation was 2 1/2 meters deep and 10 meters wide. The vertical scale on this drawing is exaggerated. Technical feasibility tests completed to date at the Tropic Test Center include 2 trenches each of 200 meters in length, 1 trench of 100 meters in length, and 2 trenches of 50 meters in length. Technical feasibility tests that are part of the Tropic Test Plan that are yet to be completed include 1 trench of 300 meters in length that will contain 9,000 pounds of blasting agent, 1 trench of 100 meters in length, 4 trenches of 50 meters in length, and 50 craters. The material developer also plans to forward Texas hardware from a third contractor for Tropic testing.
All right, ready, Ed? Camera rolling.